Let's have another example. A race car starting from rest accelerates at a constant rate of 5.00 meters per second squared. What is the velocity of the car after it has traveled for 30.5 meters? How much time has elapsed? And then calculate the average velocity. Okay, so first, we are going to draw a frame of reference. For example, this is our frame of reference, Cartesian plane pa din. There is no direction indicated in the problem, so assume na it is going to the right. Kasi the natural tendency para sa atin na magbasa is from left to right. So there is a race car, so that means magdraw na po ko car, frustrated drawer kay ko. Di ba? Perfect. So this is the start of our motion. And then take note of what is the description of the motion at the start of motion. At the start, ano ba yung motion ni car at the start? The race car is starting from rest, tama? So at the start of its motion, the velocity initial is what? It should be 0 meters per second because it starts from rest. That's the initial motion, initial description of its motion, okay? Now, from rest, it accelerates at a constant rate. So that means there is an acceleration, okay? There is an acceleration of 5.00 meters per second squared. There is an acceleration. Okay, so that means after that time, ang car natin nandito na sa kabilang side. Dito na banda, car natin. Ayan, di ba? Perfect na yung car. So nandiyan na yung car natin after some time. And after it accelerates, it has traveled for, pila man na, 30.5. It has traveled for 30.5 meters. Ibig sabihin, from this point, from the starting motion until this part here, the displacement is 30.5 meters. Nakuha? So there is a displacement. So that means we now have an idea on the problem. So meron kang initial velocity na 0, it accelerates at 5 meters per second squared, and then it has traveled for 30.5 meters. Then, identify what is required. Ano ba yung required natin? Required. First required for letter A, unknown is the velocity of the car after it has traveled. So the velocity of the car after it has traveled. So that means the velocity at this point. Okay? So this is the end of the motion, right? So that is our final velocity. Do you follow? So A, final velocity is unknown. Okay? Next, for letter B, unknown is how much time has elapsed. So unknown si time. And then for letter C, calculate the average velocity. Yan, average velocity. Basta may bar sa taas, average. Okay? So let's start first. Tapos na tayo ma-identify lahat. So balik tayo ngayon sa equations natin. Ano ba yung mga equations natin? First, D is equal to V times time. Acceleration is equal to Vf minus Vi over time. We have twice acceleration displacement, Vf squared minus Vi squared. And then we have displacement is equal to Vit plus 1/2 At squared. So these are the equations. So balik tayo ngayon sa equations to help us choose an equation that suits best sa ating given values. So for letter A, we are going to solve for the final velocity. And take note, this is constant acceleration. Tama? Constant acceleration yan. If that is constant acceleration, we cannot use the first equation for the letter A na part. Okay? So pili tayo dito sa tatlo. So VF, identify natin saan yung may VF. So dito may VF, yan may VF. So check natin kung kompleto ba yung details. Do we have acceleration? Yes, there are acceleration. Do we have initial velocity? Yes, there is an initial velocity. Do we have time? Walang time. Tama? So if hindi kompleto, that means you cannot use that equation. Hindi siya kompleto. Okay? So move on tayo. Move on tayo doon sa kabila. Ano pa ba yung may velocity final? Ito, there is a velocity final. So let us going to check if ever we can use this equation. Do we have acceleration? Yes. Do we have displacement? Yes. Do we have initial velocity? Yes. So that means we can use this equation. Tama? How about the fourth equation, sir? We cannot use this equation. Bakit? Kasi wala tayong time. Kasi puro study. So we are going to use the third equation. Okay? So to solve for the third equation, wait lang. Ayun. So we have twice the acceleration, displacement, velocity final squared minus velocity initial squared. Okay? Follow. So we are going to transpose. Kailangan natin si velocity final squared. So we are going to transpose the velocity initial to the other side. So Vf squared is equal to 2 times acceleration, displacement, plus the initial velocity squared. Okay? I hope it is clear. However, your initial velocity is 0. Tingnan mo yung given natin. Initial velocity is 0. So that means this term is not significant. Maging 0 man din yan. Okay? So tanggal na yan sa equation. Initial velocity kasi 0 yon. So tanggal. Now, if you notice, there is a square sa ating final velocity. If there is a square in our final velocity, then we are going to take its square root. Square root. So that means our final velocity is equal to square root of 2 times acceleration times displacement. Ito ha? So this is our formula. So we are going to substitute all the given values. 2 times our acceleration. What is our acceleration? 5.00 meters per second squared times our displacement. What is our displacement? 30.5 meters. And that will give us final velocity is equal to square root of, ilang may answer ani nila? This is 305 meter squared kasi dalawa yung meters squared per second squared. And then take the square root of that. If you take the square root of that, pila man na? Square root of 305. That is 17.464 and so on meters per second. Meter per second na lang kasi may square root. Okay? But remember, we need how many significant figures? We need 3 significant figures because if you notice, 3 significant figures. So we only need 3 significant figures and that will give us 17.5 meters per second. Okay, let's proceed with the second problem, time. We are going to solve for time. Time. For letter B, unknown is time. First, identify natin yung mga given values. Ano-ano ba yung mga given values natin sa ating dito? So we have initial velocity which is 0 meters per second. And then we have acceleration, which is 5.00 meters per second squared. And then we have displacement, which is 30.5 meters. And then we have the final velocity, which is 17.5 meters per second. Tama ba? 17.5, 30.5, 5.0. Tama. So balik tayo ulit sa equations ng kinematics. First equation we have D is equal to velocity times time. Acceleration is equal to Vf minus Vi over time. 2 acceleration displacement is equal to Vf squared minus Vi squared. And then we have D is equal to Vit plus 1/2 AT squared. So we're going to identify which equation will fit will fit to our given value. So we are looking for time. Asan ba dito yung my time? Wala, my time. However, are we going to use the first equation? Of course not. Hindi pwede ang first equation. Bakit? Because we are dealing with acceleration. And first equation is for constant motion. Okay? So proceed tayo sa second equation. Uy, hala, may time. Pwede ba ito? Check natin kung the rest are given. Acceleration, yes, there is acceleration. Final velocity, yes, there is final velocity. Initial velocity, yes, there is initial velocity. So that means we can use this equation. Okay? Sir, how about the fourth equation? My time, sir. Tapos meron tayong displacement, meron tayong initial velocity, meron tayong acceleration. Yes, pwede din. So we are going to use the second equation. A is equal to VF minus VI over time. And since we are going to solve for time, you just derive that equation. I'm sure magaling na kayo nito kasi ilang math na yung napagdaanan. And if you watch the video doon sa YouTube, mayroong formula sa time doon na it is velocity final minus velocity initial over acceleration. Okay? And take note, our initial velocity is 0. Ang initial velocity natin 0. So that means it is not significant. Yan, hindi yan significant. Luuya sa 0, no? Char lang. Ako yung naluoy sa 0. So VF, our final velocity is 17.5 meters per second. So copy, 17.5 meters per second. Since 0 naman yung initial velocity natin, yun, well, hindi na yan kailangan. Divided by acceleration. So dito sa acceleration is 5.00 meter per second squared. And that will give us, pila man eh?
3.5, sir.
3.5 seconds. How, laka, ano na? .5 seconds. 3.5 seconds. But take note, we are going to follow the rules of significant figures. And since we need how many significant figures? We need 3 significant figures. So that means 3.5 is not our final answer. It should be 3.50 seconds. Okay? So the time is 3.50 seconds. Nakuha? Diba? Napakadali lang, no? Okay na. We'll proceed with letter C. Ano yung problem sa letter C? Erase ko muna dito sa kabila, ha? Ito, erase ko muna ito. Yan. So we are going to solve for C. Ano yung question sa letter C? The average velocity. So we are to solve the average velocity. And remember, you know the formula for average velocity, right? Average velocity is equal to the displacement over time. What is the displacement? Ano ba yung displacement natin? Displacement is 30.5. So it is 30.5 meters. This is displacement. So that means there is direction. Ano ba yung direction natin? This is going to the right. So pwede din, lagyan mo ng right. Pero sir, hindi naman siya naka-indicate sa problem. That is why, assumption lang natin yan. Asumero man ko. So right. Assumption lang na ha. Pero since wala may gibutang sa problem, pwede ra po nato na dili ibutang. Gibutang lang ko na diha to indicate that it is displacement to the right. And then the total time, what is the total time? Dara? 3.50 seconds. And that will give us, pila man eh? It is 8.71 meters per, exact na, napa ni siya yung point something. Ayaw sa para makita sa significant figure. 7142 meters per second going to the right. Okay, so significant figures, do not forget the rules of significant figures. So that means our velocity is 8.71 meters per second going to the right. Ayun. Tapos, or we can convert that into kilometers per hour. Pwede po. So, you know already how to solve or to convert that into kilometers per hour. Questions?